All right, good morning, everyone. This week we're going to be diving into the realm of databases. I hope everyone has done their pre-readings and everybody liked that intro to database manga. I've been reading it myself and I think it's pretty cool. But this week is going to be a pretty light week. It shouldn't be too intense. There is going to be an assessment over this material that we are covering. But please note that databases are going to be something on the lighter side of what we cover here in Code Platoon. So today we're going to mainly focus on an introduction over all of the topics that we will be covering over the week. We will go in depth into schema design during part 2 of our lecture and actually use draw SQL to draw a schema or for a couple of data tables. But please know that this first part is going to be more of a conversation and it's going to be more us getting ourselves familiarized with good and bad practices of how to create a schema design and what we'll be covering over the week. At this point, does anyone have any questions over what we'll be talking about today? Okay, great. If there are no questions, let's go over into what is a schema design. So a schema design is just essentially we're turning our database or what we would turn into a create table statement. But rather than actually going into creating any tables or creating anything that has to do with CSV files or touching any data, we're not coding anything at this point. We're simply just thinking about what kind of relationships are within our database, right? So for example, let's say I run some sort of, let's say I run a grocery store, right? Well, what's inside of my grocery store? Well, I have different different types of food. So there's one table right there. I know that I need a table that will specify the types of food, right? And then I have individual food items that belong to each one of those types. So now I know that I have a relationship between them. And I just continue breaking them down, thinking about them. I start thinking about, well, the title of this food, should it have only characters? Should it allow for numbers? Um, what what kind of type should this field be? Should this be a Boolean field? Should this take in a long description? How many characters do I need in order to be able to actually accomplish this field? There's a lot of things that we'll go into considering, and we'll go into that here shortly. But that's essentially what schema design is. It's the thought process, right? Before, just like we do with applications, before you start making an application, you should draw it out, make some sort of skeleton, whether that's with TL draw, or if you're using some other kind of drawing tool, or you're using something like Figma to make your front end development skeleton. Just like we make skeletons for our front end and back end frameworks, we do the same thing for our database. So here we go into how to create a schema design. So good practices, normalization. We won't really go into depth as far as normalization goes. I'll share a couple of YouTube links or a couple of sources that will go over the different normal forms of normalization. But we're essentially going to be covering them without covering them in detail. So normalize your database to reduce date redundancy and improve data integrity. So what this means is you don't necessarily want too many fields to be attached into one specific entry. So what I mean by that, just like in OOP, right? We want to make sure that we follow the single responsibility principle. So something along those lines. We want to make sure that if I have multiple items within my store and all of those items have different sets of descriptions, and let's say that those items, they have subsidiary items with very minute differences. Well, because of those minute differences, I wouldn't want to create a field that's ID, item name, and then description. I may want to create a field that says ID, item name, and then create a different entry that will cover the descriptions and have a relation between those descriptions and that one item, having a 1-to-1 ratio, and then just utilizing relationships to connect those to it. Now, what comes from normalization, or what comes good from normalization, is it keeps data integrity and it allows you to quickly clean and maintain your database and also grow. We'll go into the growing of databases, since you'll know it's going to start off at this very smallest level. And as we keep going, our database can potentially grow, get more tables, And if we don't keep our database nice and clean and with following the single responsibility principle, it may become hard to even do that. Sometimes you might even have to take down all your data. Once you have all your data, destroy the original database that you have or manipulate the original database that you have so that you can make two separate tables and then include a third one in order for your table to grow. And that's what we're trying to avoid. Now, at the same time, you don't want to overdo it. You don't want a one-to-one field like an ID and then one field for everything, right? Because if you do that, then you're going to make things really hard, especially for querying. You're looking into join tables every single time you do a query. Anytime you want to add a table, there's going to be a bunch of references everywhere. So to an extent, you have to make sure that you find the right balance of how to connect those things. Does anyone have any questions over normalization? Okay, I don't see any questions here on the Whiskey channel. So I'm going to go ahead and push forward here. The next thing we're going to go over is using primary keys. So primary keys are essential for a relational database, right? Because just like it's in its name, it's a relational database. We'll be utilizing Postgres, but it needs something to have to relate to. And a primary key is exactly that. One, it is unique, it is not repeated, and then make sure that it's only keeping that one value and giving it an original value that it can be related to. Now, you could set different fields as primary keys. So far, we've seen primary keys being generated to integer fields, and those integer fields just keep on being augmented. Later on, we'll see something where we can utilize something like serial numbers to create a primary key. But you want to make sure that you don't set a primary key to something that's going to be frequently changing. So for example, let's say we're being lazy and we set a primary key to something like the name of an item. Right. Well, that name of an item could possibly change in the future, and that would take a single alter table query. We don't necessarily want that because then the next time we try to run some sort of other SQL script that references this field, it's going to go ahead and throw an error because now its primary key has changed. It has no idea how to build that relationship. And that kind of ties into foreign keys. So foreign keys have to make sure that they're established between tables. Now, foreign keys, as we saw earlier in our intro to PostgreSQL, when we did our full stack week, we don't necessarily have to establish foreign keys, right? We could just say, hey, here's an integer 5, and then we could write a statement where we can say, hey, I want you to join the tables where this item of integer 5 is the same as a primary key on another item. That's not the same thing as building an actual relationship. We'll see the syntax for it on this week, but we're going to build actual relationships, and what those relationships will enforce is the reference, right? It will know that that reference or that integer that we're using is for a specific primary key upon another table and not just a random integer number that could be used for multiple tables. Does anyone have any questions over primary keys or foreign key relationships?
We basically, I mean, primary keys, we pretty much just use IDs right now, right? Because that's the one thing that's like,
Yeah, yeah, for now we'll be, and for pretty much this entire week, we'll be seeing primary keys falling as the item's ID number, and that's what we'll be setting as the primary key. That's correct. All right. The next thing we'll be talking about is data types and constraints. So data types and constraints. We'll be going over these more in depth, but you'll see that there's a couple of examples here, right? We have not null, we have unique. There's also something that's a nullable value, which is going to be by default. Everything is going to be nullable unless we specifically tell it that it is not null. There's also other constraints that we'll be going into, and something like check. Now, these constraints are to make sure that our data that's being entered into the database meet a specific standard. So data types, or the types that we can specify for a table, sure, that covers, hey, this is going to be an integer. It covers whether it's going to be a string. We can cover how many characters that string will have and limit the amount of characters that we'll be able to accept, or give it a parent amount of characters, regardless whether we're utilizing all of it or not. But what constraints do is they kind of add an extra layer to that, right? let's say I'm taking in age and I'm taking in members to my store. Well, I want to make sure that all of those members that are signing up for my store are at least 18 years or older. Well, I can also write a program through Python to make sure that we do that. And we did that through getters and setters, right? Well, in this case, what I'm going to do is I'm going to build a constraint that will check that the data entry would actually be greater than 18. And obviously, I would have some sort of age limit, making sure that people aren't older than 100 or 110, right? Because we want to make sure that those people get removed from the database once they reach that threshold. And that's all data types and constraints are really going to cover. We'll be going into those more in depth constraints tomorrow and data types today. But at this point, does anyone have any questions over data types and constraints? All right, these are basically our enforcers. But moving on to indexes now. So indexes, it's a good practice. I think we have a hot mic. I'm going to go ahead and mute that real quick. All right. So indexes are actually really good practice. Now, indexes are a little bit confusing, and we'll be covering them in depth once we actually get to day 3 of this week. We'll be covering our queries. But indexes are something where you tell the database, hey, I'm going to be writing a lot of queries that regard this one specific field for this one data table. So what I'm going to tell the database is I want you to make sure that you create a clear, accessible path for me to be able to query this table into this one specific field, and I want you to make it as efficiently as possible. Now, when I do that and I run my query, we'll see it that it will be able to return that data more efficiently than if I didn't have an index. So that's why it says specifically where you use where clauses. Right. So let's say I have a database and I have all my clients that have signed up for a plan or whatever. They're all older than 18 so far. But I have a tendency of grabbing all those clients by a name. Well, that's where I would add an index. I would say, hey, add an index to the first name or the last name so that every time I use this query or I run a query to the database where I'm filtering by an index, it can quickly grab that information and return it. Now, its difference is minute, especially at the level that we're working with, because we won't be making very complex databases, at least not in this week's lectures. But if we were to make a massive database with a massive amount of data, those indexes would be extremely crucial to the efficiency of our queries. And we'll go into that once on day 3. Does anyone have any questions regarding indexes? Okay, if there are no questions about indexes, then we'll go over the last 2 here. We're going to go over consistent naming conventions, just like everything else. Make sure that you stay consistent with your naming conventions, whether you're utilizing a dash or an underscore to symbolize spaces, or maybe you're not using anything. Maybe you just have one specific word all the way through. If you're utilizing numbers, should those numbers only be acceptable towards the end? Will numbers be acceptable at the beginning of a name? How is it that you want to manage that? Just come up with one specific naming convention. Try to avoid special characters if at all possible, because you want to make sure that special characters are just that special. And also, you may get some unexpected behavior from your database if you're utilizing special characters in the wrong fields. So come up with one specific naming convention and stick to it all the way through. If you start mixing in names, let's say in one of them, you just have ID for a table, and there's 5 tables in a row where the primary key is just referenced to as ID. And then all of a sudden you create a table for a game, and in that game table, instead of it being ID, you have game underscore ID. Well, now that one difference could throw off any other developer or someone else that's working, or maybe you're writing a query, and now everybody has to keep in mind, oh, this one specific table has a unique naming convention for the gaming ID. And for someone who doesn't know that, or if it's not documented anywhere, they won't be able to find that. And they may run into trouble trying to diagnose the problem and finding where that problem is coming from. So please ensure that you stick to the consistent naming convention. And that goes into documentation. Anything that you do, including front-end development, back-end development, and even your database, there should always be documentation where you explain Well, one, you should include an image of your schema design so that other people can see the schema design, or at least have a reference URL to wherever that map of your schema design lives. Then there should be something that explains why there's relationships between one thing and another, what kind of relationships those are, the constraints that are applied into each individual table, and then any additional information that you think is important for a developer to know before they start working within your database. Does anyone have any questions regarding consistent naming conventions and documentation? Go ahead, Yams.
Was this a part in under consistent naming conventions where you mentioned to use lower cases and not any capitals, just because it kind of messes up how things are searched?
Yeah, that's a great observation. So for entries, you could definitely have capital letters. But if you're creating fields or you're creating tables, do not use capital letters and special characters. Just like Yam said, that will create some really unexpected behavior. Postgres definitely doesn't like capital letters, and it throws a huge error. It won't even throw you an error. It'll accept the create table query, but then it won't actually let you query the database unless you do it in a specific way. It's just avoid capital letters when you're naming those tables. Does that answer your question, Yams?
Thanks, because I wasn't sure where that applied.
Of course, no problem. All right. Well, let's talk about some bad practices now. So now, bad practices, denormalization. So just we covered this earlier, but you want to make sure that everything has a reason for it and that you're finding the right balance and consistency between one-to-one indexes, how much information is actually being stored inside of a table. If something is consistently changing within a table, should that be stored in a separate table? If something is related to by multiple tables, but it only lives inside of one of the two, that should probably be grabbed, taken out, and then put in two of them. So you want to make sure you're not constructing these normalization purposes and then deconstructing them without an actual reason. Ignoring indexes. If you took the time to create indexes, or you're not creating indexes, and you're just keeping the database and you're saying, oh, well, it'll be fine because I'm not handling information. I'm not handling that much information. You're not preparing yourself for your database to grow and for you to take in a considerable amount of data. The more data you have, the longer these queries will take. Null values. You want to make sure that null values are only allowed where you would actually want a null value. And if something you need an entry for something, you need to specify that it is not null. Relationships, we want to make sure that we enforce those relationships. Again, we're not actually we're enforcing the reference and the integrity between those two. We're not enforcing the actual number to number relationship, but just a reference from one table to the other. Inconsistent naming, we talked about that. Lack of documentation. So for lack of documentation, I know I tried to say it a lot to make sure that you're documenting everything that you do. Make sure that if you're working on some sort of personal project or your own portfolio or anything else, you're creating documentation. Try to make it fun, try to make it interactive. If you're applying for a job and they want to see the things that you've done there and you're providing them GitHub links, they're going to go to your GitHub. They're going to look through your projects and different things that you have. And if you don't have READMEs or something to make things interesting, something to actually explain, hey, this is what this project is doing, you should check it out, and maybe add like a small demo, tell them how to install on their own machine and how to run it, they're not going to take it seriously. You need to make sure that you make your GitHub as professional as possible, especially coming out of the boot camp. So now we have ignoring security. Whenever you're working within databases, Postgres comes with some pretty good built-in security, but there's other things that we can go into as far as where it's listening, where it's accepting TCP requests to actually connect to each individual port. Do you want to leave it running on the default port, or do you want to have it running on somewhere else and create an environment variable for that? And then only other developers that are supposed to interact with the database have that port. You need to make sure that there's restricted access to each individual table for the users that only you want to have access to. That way, no one is doing, you want to make sure that you're preventing the wild, wild west from happening within your database. If you're just giving people roles and permissions and these create permissions and these drop permissions, nothing stops someone from going into your database and changing something that you don't actually want to be changed. You want things to be supervised and managed as much as possible. And then ignoring scalability. I've covered this a couple of times. No, things are always going to change as your project grows. You might want to add a new feature. You might want to add something into the database. So the more you stick to the single responsibility principle, or the more you stick to making sure that there's some sort of one-to-one relationship, or that data is being extrapolated and held in the correct format, the easier it's going to be for you to just add another table, add a reference, and there you go. You have a new feature. Where otherwise you would have to go through the entire process of reconstructing your database, cleaning it up, grabbing data, formatting the data to go into each individual table accordingly, and then recreating everything and re-entering the data, which is not something that we want. Oh, and just like Cass said, no special characters in your password, please. All right, does anyone have any questions over any of these bad practices that we just talked about? Okay, if there are no questions, let's go into understanding entity fields. So in Postgres, every time we create a field, we're also going to give it some sort of data type or some sort of type for that specific field, where we're going to tell it, hey, I want you to utilize this or accept data into this one field that meets one specific format. All right, so the first one that we'll cover is going to be serial and primary keys. We've talked about this. Its usage is to make sure that every single entry has a unique identifier within the table. They should automatically increment, and they provide a unique identifier for that record. So when it should be used, well, it's to make sure that everything has a unique identifier. Preferably every single entry or every single table that you create would have a serial and primary key, unless it's some sort of description that you're just entering into the database for other developers. And then just when not to use. And that one is avoid if the application requires specific control over the values, or if a composite primary key is more suitable. We won't be utilizing composite primary keys, which is basically saying the one that we construct ourselves. We'll be utilizing the serial primary key. All right, so here we go, varchar and text fields. So varchar, which is a variable character, you can give it a limit, and it can only take up to a max of 255 characters within it. Now, I can tell it that I'm going to use up to 255 characters, or that I should accept up to 255 characters. But when it gets saved into the database, it's only going to, each entry is only going to occupy the amount of space that it's actually utilizing. So if I enter something that's only 10 characters, it will only stay at 10 characters. Now, there is something called a char field. A char field is different than a varchar, because a char field, if I tell it that it can only accept 10 characters, it does not have the ability to extend past 10 characters, and it does not have the ability to decrease from 10 characters. So if I enter something into a char field that's only 5 characters long, but I told it to be 10 characters, when I go ahead and query the database, or if I want to make sure that there's only, or I want to see how many characters there's in there, it's going to return to me 5 characters and then 5 empty spaces. Whereas if I utilize a varchar, it will return 5 characters, and that's it, no additional string. Now, you do want to make sure that you limit that varchar. It still occupies an additional amount of space than char, because it occupies the amount of, it occupies the functionality to be able to extend or decrease to make sure that it gets cut off in the proper place inside of the database. So that's the difference between varchar and char. Now, varchar and text field does not have a limit. Text field will take in as much text as you feed into it, and it will save it into your database. So for something like a description, I would want to utilize a text field. For something like a title, I would want to utilize a bar chart. And I want to make sure that that bar chart gets limited to around 15 or 20 characters, or if possible, something smaller, depending on the title. Does anyone have any questions over serial and primary keys, var char and text fields, and char? Go ahead, Jens.
Maybe it was just assumed, but the text fields do not have a character limit. Or
That's a good question. So do text fields have a character limit? From what I'm tracking, you could give text fields a character limit, but you do not have to. You could put as many characters in there as possible and it will still be able to accept them. I'm not sure if they have a max amount of input. I haven't ran into it, but I will look into that and give you feedback as soon as I can. All right. Any other questions? Okay. Next, we're going to go over numeric and decimal fields. So numeric fields are kind of like integer fields, right? We can accept one specific whole number as an integer field, or we can utilize something like a decimal field. You'll see that you can also use something like float later on, but float comes at a price, whereas decimal field, you can actually tell it how many, specifically how many decimals it is supposed to take in, and how many total amount of integers it is supposed to accept. Now, what is the benefit behind using decimal field? Well, if you are working with something like money, which most of the time that's what you'll have to enter something like that into your database, you're going to want to use something like decimal field, where you're telling it, hey, you will only accept 2 decimals after your actual integer, and then everything else will be part of a whole number. An integer field should be just for quantity, right? I'm never going to have 2.5 of in my inventory of one specific game or one specific movie. I'm always going to have 15 or 10. It's not possible for me to have half of one, because that would mean it's broken. It's not going to work, right? And then we have date and timestamps. So now dates are specifically for storing dates. Timestamps will not only store a date, they will store the date plus the additional time. So you could utilize timestamps for something like, let's say, shifts for an employee, right? If an employee has to start working, well, we don't just want the date and then a separate field for the time. We would want timestamps for each individual employee's shift. Does anyone have any questions over numeric decimal fields and date and timestamps? Go ahead, Carl.
For the timestamp, so is that specifically like inputting date and time, or like is it a way to, I guess might be a dumb question, but like actually capture date and time?
So it will, you're saying as in actually capture date and time, like as if it was a function that I could call and it would return date and time, like the current date and time. You could
Correct.
give default value to work as of now, so that whenever you create it, it will trigger on that specific time when that entry was made. But it's more for what's being accepted and what kind of data it's going to return for you. Does that answer your
No,
question?
yeah, that makes sense. Thank you.
Of course. All right. And then our final data type is going to be Boolean field, which is pretty simple, right? It's just true or false. That's all it's going to accept. And it's typically used for something like, is this user active? Is this user inactive? You'll just make an active field and then make it true or false. You don't ever want to actually delete a user unless it's been a considerable amount of time and that user is just not coming back. Maybe there's nothing there. But let's say, for example, just recently, I terminated my account with HBO Max, right? And then something came out on HBO. Don't remember what it was, but I want to go back and watch it. Well, I went back into my account, reactivated it, made the payment, and as soon as I reactivated it, all of my data from before was still there. The things that I typically watch, the TV shows that I left halfway watched, things that were in my wish list, everything was still there. Everything was still living within their database. They never removed me from their database. They just said I was no longer active, but I might come back. I'm sure that if a couple of years would have passed by and then I went back to HBO Max, all of my stuff would be gone. But they saved themselves some efficiency and kept some client data so that if I came back, I would have the pleasant experience of having all of that there. All right, so don't delete your clients, just set them as inactive. And we'll go more into that once we get into Django. All right. So now we'll cover the 3 types of relationships. And we're not going to go into these too in depth because we have a whole day dedicated to relationships and constraints. Oh, sorry, I have a question. Go ahead, Will.
Yeah, so would it ever be good practice to like put in functions for different like indexes? You know how in like Excel you put in like an add function or something just to add different cells together?
Oh, I see. Okay, got it. That's a really good question. So Will's question is it ever good practice to make an entry where you would have something like a function to create that entry? So now, if I create a function for some specific entry, so one, I'm not sure if you can actually do it in a relation database, so I have to look into that and get back to you. But I'm going to go ahead and say no, because I feel like you would want to handle that yourself, right? You would want to create, what you're going into is generating a report. And when you generate a report, that means that you're generating queries that will grab data and return that data in a specific format that you can give to some sort of client or maybe even to yourself so that you can see some sort of performance issue. That's where queries come in. And that's where you would want to utilize those sums, adds, there's average, you could do mathematical operations still. There's different join tables. Don't think about the functionality when you're creating a database or your schema or how you're storing those values. Think about functionality when you're generating a report and grabbing through queries. Does that answer your question, Will?
Yeah, yeah. So basically, you just put in the value
Exactly.
or whatever data. Okay, gotcha. Thanks.
Kara?
Yeah, so basically you're just saying that when we're thinking about the databases, we're just thinking about storing raw data that can be manipulated later.
Exactly. Yes. All right. So now going into relationships, we have these different kinds of relationships. We have many-to-many relationships, and I'm just going to stick to one example. And as I stick to this one example, we'll just go through the different types of relationships, right? So in this example, I have a many-to-many relationship. Well, what could be a many-to-many? Let's say I have a pet store, right? And inside of this one pet store, I can take in pets or a vet. Yeah, it's a vet. And we can take in pets, right? When we take in pets, we need to know owners. Well, now, if there's multiple owners, there's only one owner, that dog could have many different types of issues. So maybe I have a table that's for all of the issues that are available, right? All of the issues that I can diagnose and treat for. Well, one dog or multiple dogs can have many of those issues, right? And then what I would do is I would have a connecting table, one that's aiming at the dog or the patient, and one that's aiming at the specific issue. So then that way, that one connecting table is tracking that many-to-many relationship, right? Many dogs, many sicknesses. Now a one-to-one relationship would be where one dog comes in and only one owner is able to register, right? For every dog, I have one specific owner. And I'm sure we've all ran into that, right? Just recently I went into a pet hospital and I took my dog in and I was there with my significant other, and then they had us fill out the form, and I noticed that the form only allowed for one specific dog owner. And I told them, well, is there any way for me to put someone else on there? And they told me no, that they needed one specific person to be put into their dog owner. And without thinking anything of it, I was like, that's weird. Why would they want that? But when I think about what's going on behind their program and what's happening inside their database, they probably have a one-to-one relationship between one dog owner and one dog, right? And that's how they keep that nice and clean. And then we have our one-to-many relationships. So our one-to-many relationships could be something like treatments, right? Let's say that there's there's a specific amount of treatments, and one dog can receive many treatments, all belonging to one dog. And then depending on those many treatments, they can grab the sum of all the prices for those treatments, and that's how they generate my total cost when I go to pick up my dog. Does anyone have any questions regarding relationships? Again, that was quick, straight to the point. We have a whole day for relationships, but if you have any questions, please ask. Go ahead, Jens.
I'm sure we'll get to it later, but the foreign keys, just like the primary keys, they're also unique IDs that are generated.
That's a great question. So foreign keys are typically aiming at a serial primary key or a primary key within another table, right? We want to make sure that those are unique and that they're aiming towards unique fields that will be reinforced to be unique by our database. Does that answer your question, Jens?
Yes, thank you.
Of course. All right, so we just went over these. We talked a little bit about fields and how they're created, but now it's time to get some practical application in. We're going to talk about a couple of scenarios, and we'll create the database schema for each one of them. Now, inside of our curriculum, you'll notice that those scenarios are already built for us. So to not actually show them, I'm going to go ahead and cut off the scenario there. And I'll open up Draw SQL here. We'll talk about the scenario. We'll build our own schema. And then from there, we'll check out what is recommended by the pet store. So now here's the prompt. So design a database schema for a pet store. The store sells different types of pets, okay, and keeps track of customer transactions. Each pet has a breed, age, and price. Customer can make purchases, and the store wants to maintain information on customer details. Okay, so just from that, how many tables do we have? Anyone want to take a stab at it? Well, if I'm looking at it, right, we have design a database schema for a pet store. So that I'm in charge of a pet store. The store sells different types of pets. So here's something that gets me, different types of pets. Right, that's probably tracked by the breed and keeps track of customer transactions. So here we have breed, which is the different types, pets, and customer transactions. So I'm going to go ahead and make that. So let's go ahead and say customer transactions. We have breed, and we have pet. Or actually, I guess that could be cat or dog, right? So I guess that could be type of pet. Let me go ahead and change that.
Call that species.
There you go. We can call it species. I hope I'm spelling that right. All right, so we have customer transactions, some pet and some species, right? And then it tells me each pet has a breed. So let's go over to the pet. I'm going to add a column. I'm going to make it breed. It's probably going to be a varchar. And I don't think there's going to be any breed that's longer than 50. So I'm going to set that there to 50. All right, what else do we have? We have an age. This one, I want to make sure we stick to whole numbers. So I'm going to make it an integer field. This should not be nullable. This should also not be nullable. Well, I guess if we don't know the breed, we can make that nullable, right? And just by clicking that, we can see that there's a question mark. That makes that field optional. And then a price. So price, here's where we would go into a decimal field. Let's say total of 8 integers and 2 decimal points. That way we never get a dog that's $1,000. It could be $999.99. There you go. All right, so there's my pet table. The customer can make purchases and the store wants to maintain on customer details. Okay, so let's take a look at the customer. So one, we have purchases. So maybe we have, yeah, let's make it purchase And let's make this a decimal point with 8 and 2. Or I guess this one should be 10 and 2 in case we have a little more, right? And instead of creating a new column here, again, delete this column. I'm going to go ahead and, oh, I just made a new column again. My draw SQL skills are not up to par. I'm going to go ahead and make a customer table because I want these to be separate. All right, and let's say that for customer, I want to keep track of name. Same thing, I'm going to make a varchar. Let's say that a name is no longer than 100 characters. And maybe I want to do something like email address. And same thing, it's going to be a varchar no longer than 100 characters. And both of those are going to be required. So there you go. Now I have my customer. Maybe my species needs something like name. And now I'm able to create a purchase. Well, this customer transaction should have a I see a question, Natalie. I will get to that here shortly. Each transaction should have a customer because that belongs to a transaction, right? And I can connect that relationship. I know that every customer can have many transactions. So that will be a many to one relationship. Many transactions could belong to one customer. Okay, and maybe I have something like transaction item. Because now I have a many to many relationship. So I could say pet. And I could say transaction. So now a pet can belong. Oh, here we go. So there's a one-to-one relationship there. And then my transaction can hold on here. So I could have multiple transaction items, which will be a many to one. Oh, that's not what I meant to do. Let me go ahead and delete that. And there could be multiple pets. So that will also be a many to one. Oh. And just like that, I made a many to many relationship. And then finally, I could do something like species for my pet. And that should be a one-to-one. One species for one pet. All of them can belong to a transaction. Multiple transaction items can belong to one transaction. And I could run a query to grab a total of all of these transaction items. And that will be my purchase. And then my customer itself and all the data being retained. All right. And then to answer questions on the chat, I see one from Crystal. So would transaction items be junction tables? Yes, they would essentially have to do a join table. But the transaction item is more of a, think of it as a connecting file between customer transactions and pet. And what it does is it creates a many to many relationship, right? That's why we have this many to one and many to one on each side. Does that answer your question, Crystal?
Yeah, so I guess I don't think I understand what a junction table would be then.
That might be, I'm gonna save that question and then I'll go ahead and answer you once we get to that point in our lecture.
Okay.
But we'll cover that here shortly.
Okay.
All right, and then we have our customer transactions pet. Oh, and then I see a question from Natalie. She's asking, what's the difference between big int and int? I'll have to get back to you on that one because I actually don't know. I use big int to actually have a reference to my to my IDs. But I'm sure there's something going on under the hood that makes them specifically uniquely different. So I'll have to get back to you on that one, Natalie. I see Brian is typing. Okay, is there a reason why the relationship between pet and transaction item is one-to-many versus one-to-one? Yeah, definitely, because multiple transactions can belong to one pet, right? So multiple transaction items, I can make, maybe this person bought 2 pets, right? Well, I make a transaction item entry, 2 different ones. Those 2 different transaction items belong to one pet. Does that answer your question, Brian? That's what
But
makes it a many to
I
one.
see each pet has an age, which makes me think each pet is a single living pet, not like a pet type. And so if each pet is a single living like an animal, so each pet could have multiple transactions associated with it. Okay. Oh yeah, right, for services and things like that.
You're asking as a one-to-one, as in a pet cannot be sold twice.
I think I get it now. It makes sense. So your pet might have like multiple services associated with it.
I don't think you're in the right track, but that's not the way I was thinking about it. But I'm glad that you're getting the many to many relationship. I think that's what we concentrate on, is the many to many relationship. Because if we start overthinking it, and try to overdo it, we're gonna end up getting confused. So I try to think of databases and things in the simplest form possible, right? I have multiple pets. Maybe there's multiple pets being sold under one transaction. I need a way for that transaction to be tracked to multiple pets, right? At that point, a pet is just a transaction. Okay, awesome. All right, so I probably just made this super complicated. I'm gonna go ahead and take a look at the scenario 1 and see what we have here. Okay, so I'm not too far off. So I see that there's pets. They have a one-to-one relationship for each pet and a transaction ID. Okay, I can see that. And then we have our customers, where each customer can have a transaction. And it looks like they have a date of the transaction added into it. Oh, look at that. They even made the email unique, which I should have done as well, right? Because no two should have the same key. So I could go ahead and add that index type where I make it a unique. Okay, I was close. I might have overcomplicated it a little bit, but we got it down. All right. Does anyone have any questions over how we created this database schema? Okay, if no one has any questions, we're going to go over scenario 2. So in scenario 2, we talk about create a database for a system that tracks information about cars and their owners. Each car has a make, model, and year. Owner have names and addresses, and the system should be able to handle multiple owners for a single car. Well, let's take a look at that, right? We have our car owners and owners. And here we have a many-to-many relationship. So many cars can belong to many owners, meaning that a car can have multiple owners and an owner can have multiple cars. Now, the way that was managed is by making a connecting table here named car owners, where it's tracking car ID and owner ID. All right. Does anyone have any questions over this cars and owners table? Awesome. And thank you so much, Landon. So Landon happened to answer the question on the chat here about the difference between big integer and integer. So the difference is 1, size, where integer takes up 4 bytes and big integer takes up 8 bytes. And 2 is the range that it allows. It allows for much bigger numbers than what integer does. Thank you, Landon. I appreciate that. All right. And the next part that we'll go over is the school management system. So the school management system, design a database schema for a university management system that efficiently tracks information about students, classes, and grades. The system should be able to store details about individual students, including their names, date of birth, email, and enrollment date. It should also handle information about different classes, such as class name, instructor, start date, and end date. Additionally, the system needs to record and manage grades for each student in each class, ensuring that grades fall within a valid range 0 to 100. Consider the relationships between students, classes, and grades, and ensure that the schema supports the necessary data integrity. All right, so that was a lot. We don't have enough time to actually create this data schema, so we're going to use what was provided for us. We have the students here. First name, last name, date of birth, email, and enrollment. So we can see that that whole paragraph was actually not a lot. There was just a lot of words, right? But if we really look at this, if we really break it down and look at the requirements, we can see that the email of every student should be unique. The enrollment date seems to have some sort of note in there. We have our grades where the student ID, class ID is included, and we have a grade with some sort of comment, and it has a question mark saying, is the grade optional? So we don't have to input a grade for every single class. And then we have our class, which has an instructor, a start date, and an end date. Right? If this was mine, I would probably create, a different table for instructors where I would connect instructors to it, but seems like it's not necessary for that one schema. All right. At this point, does anyone have any questions over how to break down specific scenarios, turn those scenarios into database schemas, and how those database schemas reflect said scenarios? Go ahead, Jens.
Are there ever scenarios where a database looks circular relationship-wise?
Scenarios where it looks circular?
Yeah, like I guess I was imagining if you had classes and then you had instructors, if those instructors would then connect back to students, so it makes like a full loop. Would that ever be a case?
Got it. So you could create your database to do that, right? But that kind of goes against the whole good practices concept, right? So if we did something like that and we connected each individual student to an instructor, we're essentially multiplying the amount of data entries that we're holding, right? Whereas we could write a query that will grab all of the students inside of every class, and then inside of that query say, for all of these classes, grab the instructors, and then only return the instructor names and the student, right? And then that way we're still keeping everything in one specific entry level or one specific connecting file, and we're not multiplying the data and the amount of entries. Does that make sense, Jens?
That does make sense. I was just wondering, so if it ends up in a loop, that is bad practice, or?
Yeah, you wouldn't want it to be in a loop. So for example, let's say I have this pets, right? And let's say that I wanted to add something like, okay, well, once it gets sold, I wanted to register the owner. And I turn this into an integer field because as we just learned, and I have it be nullable, right? So it's not option. I mean, it's not a requirement. It could be empty. All right. Once it gets sold, well, then I add that owner in there. Now I have a full circle. But we can see the problem, right? Every single time that owner gets sold, I have to make sure that this gets changed, where I could just utilize the transaction item to figure out which transaction was made. And once I have which transaction was made, I could grab the customer that belonged to that pet. All right. That way I don't have to make this circular motion. And I could keep that field that is nullable with a reference out of my database. Does that answer your question, Jens?
Yeah, it does. Thank you.
Of course. All right, great. If there are no other questions, we're going to go ahead and tackle our schema design exercise of the day. So here we have our game store assignment. If you take a look at our curriculum, we have an example here. This example has a certain amount of data. We have some action figures, employees, games, and a poster. and we have our store. So the store has our answer, but please for now, go ahead and take a look at the different data types that was provided or the different CSV files that were provided. And out of these CSV files, go ahead and create schema design or just tables through Draw SQL, where we have each individual one of these, each one of the, a table for each one of these. So let's go ahead and start with our game. All right, and we'll make this one together. So our game, gonna make a new table, name it game. And now we're just gonna break down this one game and make this table up. So what are the different fields that game can have?
Game ID and game title.
All right, so we have game ID. Oh, which we already have an ID actually. So let me go ahead and change that here. So we have our game ID and we have our game title. Okay, so our game title, what should this be? Should this be a varchar, a char, or a text field?
I'd say a varchar because it has a number 3 in the name, but I don't know.
Awesome. So let's go ahead and make it a varchar and let's give it, let's say 30 characters. I don't think any of them are above 30. Okay, and this should not be nullable and it should not, well, yeah, it should be unique, right? Because every single one of these games should have a unique name. Oh, okay. I apologize, everyone. I might have clicked my mouse a little bit weird. All right, so let's go ahead and make this unique here. What else do we have?
A quantity and a price.
Okay, so let's go ahead and make our quantity. And what should our quantity be?
An integer.
Okay, let's make it an integer. And let's see, do we want to add any primary keys or unique? No, we don't. But maybe I want to add some sort of comment here. I want to say should always be greater than 1 and will never have more than 50. Right, because I think that's the maximum number that we have there. Okay, great. So there's my quantity. So the last thing that I have here is my price. What should my price be?
Should be a decimal.
Yeah.
Great, so let's go ahead and make a decimal. How many total number of integers should it take in?
Maybe
Okay, let's make it 4 and a total of 2 decimal points. All right, and just like that, we created a schema for our data table of game. Does anyone have any questions over that?
Yeah, just to clarify, for the integers on the decimal, is that total number of like numbers in the entire number, or is that like when you say 2 decimals, is that included in your 4 integers? What am I asking?
Yes, yes, it does. So that to understand your question, we're breaking down decimal, right? I am telling decimal that there's a total of 4 integers, that is 3999, and I am telling it that the last 2 of those 4 will be the amount of decimal places. So 39.99.
Awesome, thank you.
Of course. All right, if there are no other questions, I'm going to go ahead and open up the breakout rooms. You can work as a team or individually, and you are going to tackle creating a table through Draw SQL for an action figure, games, and poster. Let me go ahead and pause the recording here. All right, welcome everyone. we're gonna go ahead and go over the second part of our lecture today, which is gonna be essentially just going over schema design and actually creating some schema, utilizing some SQL scripts. All right. Apologize, I'm making sure I'm not losing signal while I'm teaching. All right, so the first thing that I want to cover is Postgres and PSQL. So, oh, go ahead, Kara.
Sorry, I was just saying we still had some people in the breakout rooms.
Oh, thank you so much. Let me go ahead and stop the recording. Thank you, appreciate it. Let me go ahead and close out those rooms. Okay, perfect. Everyone is in now. Let's go ahead and resume our share and let's resume the recording. Okay, we are good to go. Let's go ahead and continue our lecture. So what we're going to be covering here is going to be the second part of our lecture, which will cover how to actually turn this schema design into database tables. Well, before we actually go into writing any code, I want to make sure that we understand the difference between PSQL and Postgres. So Windows users, I'm sure that you've noticed that the first time when you entered Postgres, you had to actually change your user into Postgres before actually entering through PSQL. Well, why is that happening? Well, if they're both essentially the same thing, why is it that you have to sign in as a different user to be able to access this database? Well, that's because they're not the same thing. P-SQL is actually just a tool that you can utilize to access different types of databases. It doesn't necessarily correlate to PostgreSQL or any database in particular. It's actually just a tool, just like Git is, right? Git is a tool that I can utilize to make different branches and keep version control. Well, PSQL is something that I can utilize to enter any database or the majority of databases through P-SQL. So I could have a couple of databases deployed. I could have different types of, I can have different types of databases living in my local machine. Maybe some of them are living within Dockerized containers, but I don't actually, there's no correlation between PSQL and Postgres. I make that correlation because PSQL tries to access my default server for where my database would be located. So for example, if I type in PSQL right now, I should receive this fatal error, which I can see here, which tells me that there's no connection named Francisco to a database named Francisco Aula. And that's true. I never made a database for myself on purpose because I wanted us to see this error. So we can see PSQL connection to server on socket 5432. So PSQL doesn't connect to Postgres, nor does it have any sort of magical thing happening in the background that's telling it, hey, I want you to connect to PostgreSQL. Instead, by default, it's connecting to port 5432. And it's assuming that there is a database that's running and listening to port 5432 to accept request. If there isn't something in there that's being able to accept this request, or it can't process the request that I'm trying to process, it's going to tell me this connection is server on socket 5432. Postgres is running. I can run brew services here. And as I run brew services, it might take a while, but we can see that Postgres is running. It is connected to port 5432, but because I didn't have the correct database, it wasn't able to connect successfully. So PostgreSQL is completely separate than pSQL. So now I can utilize pSQL to enter Postgres, and I could do something like this, right? But that's not what's actually happening. When I run PSQL Postgres, it's not just saying, oh, I'm going into PostgreSQL and accessing the database Postgres. So what's actually happening is it's going into PSQL. It's looking at the host, local host, which is the assumed value. It's looking at the port 5432, which is the assumed value as well. And then what I'm passing in is that the user is Postgres and that the database that I want to enter is Postgres. So pSQL is a tool. I'm utilizing this tool to enter a SQL database where the database is living within my local host. The host is my local host. The port is port 5432. The user is Postgres. And the database is the same as the user, which is Postgres. That's what's actually happening when I type in PSQL 5432. And actually, let me go ahead and make a README here and add that in there. All right, so now when I run this, all right, I got a failed and it's telling me Postgres does not exist. So the role Postgres does not exist. Okay, so what if we run -h, right? Localhost -p 5432. Now I'm going to pass in my actual user, which is Francisco Avila, and the database, which is Postgres. Well, that worked, right? So we can see that I entered as myself as the user, and I specified the database Postgres living within my local host at port 5432. Does anyone have any questions about how pSQL is able to connect to PostgreSQL? Okay, it doesn't seem like there are any questions. Inside of our curriculum, you could check out a cheat sheet. That cheat sheet has different Postgres commands and pSQL commands, and it's important that we understand the difference between those two commands. Now, pSQL itself is a tool that has come in from being able to install Postgres. When we ran brew install PostgreSQL, we also installed pSQL so that we could communicate with it. Now, we have all seen, if I do something like, give me a second here. If I check out Postgres and I look at my list of databases, these are the current databases that I have. I have a car shop, Postgres, student pairing, and it looks like I have a couple of default templates. All right. Well, I can create a database by running a terminal command, create DB, and I can say store. And I'm just going to do DB so that I know what it is. Well, now let's run into PSQL store underscore DB. Well, we can see that the store was created. If I run /L, we can see the store DB was also created. But that terminal command, that one of create DB, is not something that's normal or regular to Linux. That's not a regular Linux command. This create DB shortcut actually comes from PostgreSQL. So PostgreSQL gives us that shortcut so that we can create databases or drop databases as we wish from the terminal. All right. Does anyone have any questions over create DB or drop DB? All right, there are no questions, so I'm gonna go ahead and move forward here. So we have this table here that we've created, and we created the schema of this table. But how do I actually make this table into an actual SQL design? Well, with SQL, the first thing we want to do is we want to check if the table exists. And if it does, then we want to drop it. And we've seen this syntax before. We're going to say drop table if exists. We're going to pass in game. So there's my game table. The next thing that I want to do is I want to actually create set table. I'm going to say create table game. And I'm going to pass in my arguments for set table. So there we have our create table. We can see that I have a semicolon next to that closing parentheses, which is what's actually going to run my command. All right. So now let's actually create this table this schema that we created, and let's make that into an actual SQL table. Well, my game ID is pretty straightforward. I'm going to go ahead and say game ID. And I'm going to say that that is going to be a serial primary key. After that, I'm going to make a game title, which we know should not be null, that it should be unique, and that it is a varchar, and that should actually go first, that will not allow anything longer than 30 characters. Okay, then we have our quantity, which should be an integer value. I'm gonna check out that comment that I made real quick just to see what it is. So it should always be greater than 1 and will never have more than 50. That sounds like a constraint, so we're not gonna worry about that just yet. And then the last thing we have is price, which should be a decimal and should have a total of 4 integers and 2 decimal places. And because this is my last entry on line 7, I will not place a comma at the end. And instead on line 8, I will close my parentheses with a semicolon. Does anyone have any questions over how I turned this schema into a SQL create table query? Go ahead, Natalie.
Yeah, it's just a quick question. So in between your title, like game ID and game title, and then your I'm sorry, the word is escaping me, the serial primary key and all that stuff, does the spacing in between matter? Like let's say if you're adding like tabs or something so that they're more lined up with each other.
Huh. Well, usually Postgres is pretty sensitive about that stuff. We could try it out. It looks like it doesn't matter. And I'm going to assume that it doesn't matter because it's looking for that comma to separate commands. But let me put a bunch of spacings to see what it does here. And then we'll experiment and check that out here shortly.
Okay,
All right.
thanks.
Of course. Okay, well, let's try to, oh, go ahead, Jens.
So this is a SQL file. Does the indenting matter like in Python?
Could you say that one more time?
Since this is a SQL file, does the indenting really matter on lines 4 to 7, like in Python?
Got it. Since this is a SQL file, does the index really matter? As far as I know, no, but let's try it out and let's see what it does. Let's make sure this syntax works out. So now that we have this create table, let's actually run this table inside of SQL. And I'm going to do it the simplest way possible, utilizing pSQL. If I run ls here, we can see that I have my store.sql located there. And we know that I have the store database that I've just created. So I'm going to utilize pSQL to access the store database. And I want it to execute the file store.sql. So again, I'm utilizing pSQL to enter the store database and execute the store SQL file. Notice I didn't have to use any sort of absolute path because currently my terminal is providing that path to SQL for me. It's saying, hey, here's the file. It's already here. I have access to it, and I want you to run it in SQL. Well, now when I ran it, it tells me, hey, notice the table game does not exist. Skipping drop table. So it didn't drop the table because the table game didn't exist. And it created a table named store DB. So now if I go ahead and run PSQL store DB and I run /D, I can see the relationship here. I have a game and I have a sequence, which is my serial primary key, which is a separate table that will ensure that this continues going up. And if I run a select query, we can see that I have a game ID, a game title, quantity, and price. Notice that none of my indentations or none of my tabs were taken into account. And that is because it is looking for a comma. I'm so sorry. I think there is a hot mic somewhere. Whoever has a mic on, please go ahead and turn it off. You can see that none of the indentation mattered or the indentation, and that's because SQL knows to look for these commas to identify the next line. Now, it is important that you do tab it in just so that other developers, won't have can actually read your code and no one will have an aneurysm. All right, does that answer your question, Natalie and Yams?
Well, thanks.
Yeah, thank you.
Of course. All right. So now I was able to do go through SQL and create that information. I'm going to open up another terminal here. All right, so now I have a SQL terminal and one terminal that's actually just living inside of my local machine. And the next thing I'm going to do is I'm going to try to execute the SQL or the SQL file from PSQL. Well, I can't do it utilizing, from PostgreSQL. I can't do it utilizing pSQL because pSQL is not a Postgres command. I'm currently within Postgres, right? So instead of utilizing pSQL, I have to utilize the -I command. And -I will run or execute the store SQL file. But store SQL, it has to be able to find it. And I can't use a relational path here because it doesn't know about it, right? Postgres does not live anywhere near the same directory as my my current code does. So instead, I have to grab an absolute path, which is here. I utilize the print working directory command to grab my absolute path. Now I can go over here and tell it that I want it to execute the SQL file that's within users, my user, inside of my desktop, inside of Whiskey Demos and Notes, in the directory Whiskey, in the directory 6 PostgreSQL, Schema Design, and then finally I can tell it store.sql. And now when I run this, it was able to execute the file. It actually dropped the table because it did exist, and then it created the table game. And now if I run my select query again, I should have all of the same fields. Now again, I had to utilize an absolute path for this /I within Postgres because they do not live on the same place, right? PostgreSQL lives in a completely separate directory that is attached and kind of running in the background as a background service, whereas pSQL is a terminal command that's available for me, and I could just run pSQL, specify the database, which in this case is store DB, and then tell it which one of the files at the current directory that I'm on is it that I want it to execute. Right? One is being ran through pSQL, which is a terminal tool or a tool that I can utilize to access PostgreSQL or any other database. And the other, which is -I, is something that belongs to PostgreSQL, but because it doesn't know about the remaining existence of my computer, I have to give it an absolute path so that it can find the correct file. Does anyone have any questions regarding the two ways to execute SQL scripts within Postgres? Go ahead and ask.
Either way worked fine, right? It's up to personal preference, one way or the other, to use which method.
Yes, that's correct. Both ways work perfectly fine. It's all user preference. Jose?
I thought I heard you mention that pSQL is able to be used to modify and access Postgres or any other SQL database. Is that true? Like the pSQL terminal interface is able to be used with any SQL, or is it just Postgres?
Yeah, so you could utilize pSQL to access other type of SQL kind of databases, like MySQL, that would still utilize pSQL to connect to it. But Postgres, pSQL is just a tool that I can utilize on my command line to access different databases. Does that answer your question?
Yep. Thank you.
Of course. And I think Michael had another question.
Oh, we're good now. I just wanted to know if you would ever use one over the other, but I think the answer is no, so that's easy enough.
Okay, awesome. All right. So now pushing forward, now that I have this information, well, now how do I have it copy data from the current location into my store.sql, right? So I have this data, and I wanted to grab it from game.csv. Interesting. Okay, so that's not working. I wanted to show you guys the prettier extension that just makes it look like actual Excel sheets, but it looks like I don't have it installed in this machine. I apologize. But we have this game.csv. I have a rainbow CSV extension, and that's what's causing these colors to populate the way they do. And it lets me know that I have the correct number of rows and columns. So now I have all this information. I'm ready to go. I can confirm that everything matches: my game ID, game title, quantity, and price. Great. Well, now I have to actually copy it and run it within my file. So now I'm writing regular SQL queries, right? And what I want to do is I want to run a copy command. And this backslash here is just avoiding any sort of permissions or authentication issues that I may have. So I'm doing a backslash to avoid all of that. And I'm telling it that I want to copy the table, which is game. And then I'm giving it a from. Now, here's where one or the other starts to matter. All right. I'm going to go ahead and use a relative path here. I'm going to tell it that I want it to go from this directory into data and find game.csv. And then after that, I'm just going to say with CSV header. All right, there's a CSV header. I want you to recognize that so that it doesn't read the first row. And I want you to copy entries of game from .data game.csv. Well, let's go into my terminal that's running pSQL. All right, so this is just my regular terminal. I'm not inside of Postgres. I'm going to run pSQL to enter store DB and then insert this data, or actually execute this SQL file. Well, when I run that, we can see that it was successful. It dropped the table. It then recreated the table, and it copied 10 of them. So now let's run a select all query again. So select all from game. Oh, sorry about that. I'm in the wrong terminal here. So let's go back over to our SQL terminal here, and let's run select all from, and actually it might be beneficial if I put them side by side. There you go. So now select all from game. And when I run that, we can see that it gets executed. We have my game ID, game title, quantity, and price. And it's all listed right under in the correct rows and files. So everything worked well utilizing pSQL. But now I'm about to run into a problem when I utilize the /i. So here's my /i. I'm using an absolute path. It's going into users, Francisco, then the desktop, the correct database schema, then executing store.sql. Well, I didn't run into a problem, which is actually surprising. I thought it would. It was actually able to find my correct file. And because it was able to find my correct file, it was able to execute this relative path to actually copy information and insert it. Well, now what happens if I try to use this query here and I insert it into Postgres? Right? Would this be able to work, or will this throw an error? Does anyone want to take a guess? Go ahead, Brian.
I'm guessing it'll throw an error because it's like a relative path and it needs to know exactly where the file is.
Exactly. So if I execute this, it's going to tell me, hey, I have no idea where this is at. Oh, let me go ahead and comment this out. Let me actually drop the table. Oh, I would have to create the table all over again. Huh. I am getting some really unexpected behavior. It was actually able to find the file somehow and insert the correct CSV. I have to look into that. I would suspect that other people would run into a problem if you do with your individual machine, but try not to do this where you're copying from a file inside of your database. If you do it within a SQL file to avoid any problems. I apologize, everyone, for that confusion. All right. So moving on, we just covered how to drop a table if it exists. We covered how to create a table syntax. We turned this game schema into an actual table with SQL context, and we were able to copy individual data into our database. That's quite a bit. At this point, does anyone have any questions about how we were able to create this schema and how we were able to copy the data from game.csv into store.sql? Okay, it doesn't seem like there are any questions. So now moving forward, this is all the actual SQL topics that we're going to be covering today, but I want to cover the database URI. We've seen it before, and it's something that you're going to encounter depending on the framework that you're working with. For example, if you make a project in C#, you have to specify the URI of where your project is located. And it's important for us to be able to break this down. So just like in SQL, I'm going to go ahead and close this one here. So just like in SQL, we can enter a database saying pSQL -h, specify the port, which is localhost. Oh, sorry, specify the host, which is localhost. We can specify the port, 5432. The user, which in this case, it's Francisco Avila. And we can specify the database, which let's just say that it's Postgres, right? Well, that's our SQL command to be able to enter. And we can understand what each one of these flags does and what each one of these flags does and what it's actually rendering or being updated, right? But if we go back to our full stack week and we open up our app from our server that we created in Flask, notice that's not the same thing that we created here, right? We have a URI. And this is how SQL Alchemy is able to find the URI. Well, one, it knows that it's looking for a database of PostgreSQL. But just like before, it's going to assume the local host. So first we tell it our user. We tell it Francisco Avila. If we wanted to also add a password, we could add a password here. If I wanted to have a local host, so I would then tell it this is the user and the password for PostgreSQL. And I wanted to enter at the host, local host, which we covered here. If I wanted to place 5432, that would go there, which is the port where my password is currently running at. I mean, where my, I apologize, where my local host is currently running at, which seems to have been erased. All right. And then finally, I would specify the database that I wanted to enter, which is -d. In this case, we were entering students. And in the one down in my terminal, we're entering Postgres. And that's the URI. Does anyone have any questions regarding URIs?
So the URI is basically just to like authenticate with their information on that port.
So the URI is essentially, it's doing the same thing as pSQL is, right? It's connecting me to the specific database, and it's allowing my server to connect to that database and create this model and grab data by querying the database, because it's actually connecting to it. It's running a pSQL command under the hood. Well, not actually pSQL, but it's running a command similar to it under the hood that's allowing me to connect to Postgres by authenticating me and grabbing the correct database at the correct port. Does that make sense, Michael?
Yeah, I forgot. I remember where we're at now. And
Okay.
the SQL alchemy and everything. So yeah, the password thing I think just got me, but I recall that was mentioned before. Yeah, thank you.
Of course. All right, I see a couple questions here on the chat. Is there a difference between integer and serial for primary key? Also, why do we not set price and quantity to not null? Oh, interesting. Did I not do that? Yeah, so price should not, quantity and price should not be null. Right, because if I didn't have the item, then why would I even make an entry for it? And we definitely want there to be a price, so let's make that not null as well. That's a good catch, thank you. And I believe there was something else here. Oh, difference between integer and primary key. Okay. So by making a serial primary key instead of an integer primary key, as we saw in our database before, let me see here. Because I ran the serial primary key, we got another table that was automatically generated for us called game ID sequence. And this is keeping track of the sequence of the game ID. So if I select all from game ID sequence, and I run that, we can see that it keeps track of the last value. It keeps track of a count of the many entries and how many times it is called. So currently, if I run select all from game, we can see that I have these. And now if I were to make a new entry, oh, how could I make a new entry without making this overcomplicated? Let's see. That might be a little bit out of scope out of our lesson to be able to demo it, but essentially what it's doing is it's making sure that every single time there is a new entry, it will go adding, meaning that the next entry that goes into the game will go to game ID 11, and then game ID 12. And if I remove line 6, it won't try to reinsert something into line 6 or try to regenerate a line 12. It will move into 13 and so on. Does that answer your question, David?
Yes, thank you.
Of course. All right, from Natalie, we have, is there a reason why we didn't use a delimiter when we copied the data from the CSV file? Is the comma a default value? It's a great question. So if you want to specify a delimiter, if you're using something else other than a comma, you could definitely can. But yes, essentially the comma will be the default value. If you want to utilize something different, you can specify the delimiter command. All right. The next one is Michael. We have, is there a specific way we should name the schema file, assuming they use this in the industry? That might be a better question for some of the students here that have actually had some experience doing data analytics. So not to put you on the spot, but I believe Landon and DJ, you gentlemen have some background on this. Would you want to iterate on the naming conventions for industry standard?
I believe Landon's got a lot more experience than I do.
All right.
I've seen, yeah, so for like the DB schema, it's normally just DB underscore schema, and usually the front end of the file name is your the name of your database. So if we name this store underscore schema dot SQL, that would probably be the name for like the setup of your database, but you're rarely ever going to call this again unless you're migrating or trying to drop an entire database or recreate it somewhere else.
Awesome. Thank you, Landon. All right. And now we have one last question from Natalie. Is it customary to always drop the table so that it can continuously update the table, or would there be a specific situation to not add that for a table? Currently right now, what we're doing would be for creating our general database schema, and we would be utilizing something like dummy data to make sure that our schema actually makes sense. That's the reason why we have this drop table here. If it's something that actually is concrete and you already have data already in there and you don't want to drop the table necessarily, at that point you would start utilizing alter table commands, and then you would alter specific fields and update them with the correct values. Does that answer your question, Natalie?
Yeah, that does. So then we'll learn more about that later this week then.
Exactly. Yes.
Okay, cool. Thank you.
Of course. Go ahead, Landon.
Yeah, Francis, do you mind if I say something about the drop table stuff?
Yeah, of course.
So like this is kind of like your setup script. So you have a lot of things where you'll drop a table, and then as the whole file executes, it'll drop anything that's on that database, basically make it blank, and then you run through it and it'll populate the database with your tables. Then you like more advanced stuff, you'll start dropping tables that are temporary tables. It's just think of it as like placeholder tables in a script, and as it executes sequentially, you want to drop that from memory. And that's when you'll use a drop table command, but it's on temporary data structures in your database.
Awesome. Thanks, Landon. All right. Seems like those are all the questions we have here on Whiskey Chat. We covered a little bit about our Postgres URI, but let's take a look at what PSQL can do with our Postgres URI. All right. So currently right now I'm within my database. If I utilize Postgres or PSQL to enter, let's say I do something like I want to enter a PostgreSQL database. This PostgreSQL database, I want to use Francisco Avila as the actual user. I'm going to specify that I want to enter a localhost at port 5432. And the database that I want to enter will be my store underscore DB. Okay, so I'm going to execute that, and we can see that PSQL, even though it's in a completely different format and I'm utilizing a URI, it was still able to conduct a command. As it was able to identify it was working with PostgreSQL. It grabbed the user that I was trying to use, passed in the local host and the port, and then it passed in the store DB. So this works great. And this is good because now if I'm working within an app server, or I'm trying to actually create some sort of server with Flask, and I'm working with the URI, I can pass in the URI straight into PSQL and confirm that it works. And if it throws an error here in PSQL, well, then I know there's a problem with my URI. Does anyone have any questions about URIs? Okay. If there are no other questions, that is all the content we had for today. The next things that we have for the remaining of the day is going to be creating an actual table that will be able to copy data from the CSV files that we provided for the remaining CSV files. So currently we created one for game. Now we're going to take what we learned today, create one for action figure, poster, and employees. Does anyone have any questions about this afternoon assignment? I think Landon, you just have your hand up. Is that correct? Yes.
Yeah, that's sorry about that.
No problem. All right. It doesn't seem like there are any questions. I'm going to go ahead and stop the recording.